Well, let's see. I want to show you how you can write a subroutine. In this subroutine, I would like to read pin B and loop and wait until pin B is a low. So I've already written the main program, which is up here, and it has the org at 0, and then we're going to set the DDRB such that PB1 is an input, which is this 0 right here. That 0 right there pertains to PB1. Also, by the way, PB0 is also set to an input, and that's fine as well. Then I will call the subroutine, which is called wait for low, and that's going to be down here. So I put the label wait for low colon, and the first thing I need to do is to do in into R16 from pin B, and that gets all 8 bits, mind you. We want to extract just one of the pins, the PB number 1. So I'm going to say and immediate R16 with the pattern that keeps only that 1 bit, PB number 1. That 1 keeps PB number 1. Then we're going to compare immediate the R16 with the pattern that I desire, which is all zeros and a 0 at PB number 1. So it's this 0 right here that pertains to the 1 in question. Next, we need to branch if we're not equal to more input, or wait again. So I'll branch to wait for low, and otherwise I go back to where I came from, and that would be the return RET. So let's see if this compiles, see if we made any errors. No errors. And that is the code. And I'm going to put a marker here just for fun so you can visually see where the subroutine starts and stops. It's kind of a nice visual effect. So again, in, and, compare, branch, and then return. You know what? I was just thinking, this subroutine changes R16. You may not want that to be the case. R16 could be remembering something very important back in the main program. If you don't want this subroutine to clobber or change R16, you do this. You say push R16 onto the stack, and then when you're done, you can pop it off the stack. If you forget to pop it off the stack right here, you won't go back to your main program. It'll just, die a painful death when you try to run this. It just won't work. So for every push you have up here, you need a pop so as to reinstate the stack to the original location such that you can return to where you came from. Well, that'll be the end of this demonstration.